As I mentioned to you, for understanding the negative indices, we need to understand the positive indices also. I mean, indices means here, you know exactly it is powers, exponents. We can use exponent for that one or power for that one. And here, as you see, these are very simple. That's why when you are talking about 5 to the power of 3, or when you are talking about 5 to the power of 3, it means that here you should multiply the 5 by itself 3 times, which is equal to 5 times 5 it has to be, or 7 to the power of 4 as you see. And here, of course, these are simple, but this kind of questions, when you see in the exam, you are going to count how many. You have 8 here. There are 6 8s. So the answer is going to be equal to 8 to the power of 6. Here, the one of the important part was on this lesson. It was this law of powers. And when we are multiplying the with same basis, you should add the powers, like 2 to the power of 3 times 2 to the power of 4. It should be equal to 2 to the power of 3 plus 4, which is equal to 2 to the power of 7. Or if you have 2 to the power of 7 divided by 2 to the power of 4, or 2 to the power of 7 divided by 2 to the power of 4. These two both same. You know that one.
Yes.
Then the result is going to be equal to 2 to the power of 7 minus 4, which is equal to 2 to the power of 3. And the last one is 5 to the power of 7 to the power of 2 is equal to 5 to the power of 7 times 2. Power of power is equal to 5 to the power of 14. It has to be. And here, these are the examples, and we already solved this kind of things, but we should know this one here. When the numerator and denominator is same, I mean, here, numerator and denominator same, the result, it has to be equal to 1. And for any number to the power of 0, it has to be equal to 1. So here I mentioned many numbers like 7 to the power of 0, 2 to the power of 3 to the power of 0. Any number to the power of 0 is equal to 1. And here minus 2 to the power of 0 is also equal to 1, because it should be minus 2 to the power of something. Let's say minus 2 to the power of 15 divided by minus 2 to the power of 15 again. What it should be? The same number when it is divides itself, it should be 1. So negativeness is not affecting. You should be careful about that one. Then here we had this kind of examples. These are similar to that exercises that we solved. But I want to solve some of them from here. This type of exercises now we solved. I solved in the previous pages, but this type I didn't. So I'm going to continue with this type of examples, which is 2 to the power of 2 times 2 to the power of 4, which is equal to 2 to the power of 2 plus 4 divided by 2 to the power of 3. That's going to be equal to 2 to the power of 6 divided by 2 to the power of 3. And the result is going to be equal to 2 to the power of 6 minus 3, which is equal to 2 to the power of 3. It has to be. So as you see here, when you see this fraction bar, also you're accepting that one is division, and you're applying the division rule. Here it's going to be equal to, like, let me solve this one. 3 to the power of 4 times 3 to the power of 2 is equal to 3 to the power of 4 plus 2 divided by 3 to the power of 5, which is equal to 3 to the power of 6 divided by 3 to the power of 5, which is equal to 3 to the power of 6 minus 5, which is equal to 3 to the power of 1, and that has to be 3 also. That's also important point here. When the power is 1, the result, it should be equal to itself. And this type of questions also, these are here, this one, F, G, and H. And these questions, they are a bit different than the others because we have two different variable, not variable, two different number. But here we are going to combine fives together and fours together, which means if I solve H here, 6 to the power of 3 times 6 to the power of 3, it's going to be equal to 6 to the power of 6. 8 to the times, because all the operation between them, 8 to the power of 5 times 8 to the power of 6, which is the sum, it should be 8 to the power of 11. The powers should be added, which is 5 plus 6, that's 11. And here I'm going to write the 6 to the power of 2 below 6 to the power of 6, and 8 to the power of 6 below 8 to the power of 11. So when you have this kind of operations, you may do operation between 6 to the power of 6 and 6 to the power of 2 only, which is equal to 6 to the power of 6 minus 2 times, because all operations are times here, except the fraction bar, but we are doing that one with minus 6 to the power of 6 minus 6 to the power of 2, and then times 8 to the power of 11 minus 6. It has to be, the answer is going to be equal to 6 to the power of 4 times 8 to the power of 5. And in the exam, I'm not going to ask you calculate these are because this value is huge number, and it is not easy to evaluate without calculator. That's why I'm not going to ask them. And here, this is the last question. It's going to be from this topic. Here we have the 6 to the power of, firstly, 3 to the power of 4, which is equal to 6 to the power of 3 times 4, that's 12, times 6 to the power of 3 times 4 to the power of 9, then divided by 6 to the power of 8 times 4 to the power of 2 times 4, 8 it has to be. Then the result is going to be equal to 6 to the power of 12 times 6 to the power of 3 is 6 to the power of 15 times 4 to the power of 9 divided by 6 to the power of 8 times 4 to the power of 8. Here we are going to be careful about to do operation between 6s and 4s. So which is going to be 6 to the power of 15 minus 8 times 4 to the power of 9 minus 8. This power is 8 here. Looks like 48. Okay, so the answer is going to be equal to 6 to the power of 15 minus 8, which is equal to 17, times 4 to the power of 9 minus 8, which is equal to 4 to the power of 1. Is there any problem up to now?
No.
So 4 to the power of 1, or 4 to the power of 1 is equal to 4. We are going to leave like this here. Okay, these are a kind of simple when you compare with the negative indices, because in negative indices, you should use the fractions, but it is not difficult. Also, only the difference when you see a to the power of minus m, you are going to write instead of that 1 over a to the power of m. That's the thing here. If you see 4 to the power of minus 1, it has to be 1 over 4 to the power of 1, which is equal to 1 over 4. Actually, you don't need to write 1 over 4 to the power of 1, then 1 over 4 in the exam, because directly you can write, because there's no need to write this power here. But here we have to. This is equal to 1 over 3 square, and it's equal to 1 over 9. And as I mentioned to you, here I said you don't need to calculate these numbers by using calculator. That's why I don't want you to find the decimal numbers. Unless I mentioned in the exam, you don't need to find the results in decimal numbers. But these questions, C, D, E, F questions, these are necessary. I told you the reason for that one, because all these are with powers of 10. When you see 10 to the power of minus 2, it is going to be, and in this kind of questions, we are going to find the decimal. We may find easily decimal numbers. That's why I'm asking you to find. So I'm going to skip here C. Then I'm going to continue with D. This has to be 5 times 1 over 10 to the power of 10 to the power of 3, by the way. But in the class also, I showed directly like this, 5 over 10 to the power of 3. Because when you multiply the integer by the fraction, you should multiply only by numerator. And it becomes 5 times 1 over 10 to the power of 3, which is equal to 5 times 10 to the power of 3, which is equal to 5 over 1000. And that's equal to 0.005, it has to be. And as I mentioned before, this is easy to calculate. That's why we are doing like that. And here, 10 to the power of 3, if I solve, this is the F1, this was the D. If I solve the F1, it's going to be equal to 10 to the power of 10 to the power of minus 3 is equal to 1 over 10 to the power of 3, and this is equal to 1 over 1000, and that's equal to 0.001. It has to be. And here you should calculate the decimal. But again, I'm going to mention here, we are not going to change these expressions into decimals, because these are already, I mean, it is not easy to change. 1 over 9, you should divide that one. Also, the changing fractions too. We have that one here, changing fractions to decimal. Here, there's a topic like that. If it is necessary, I will ask that question. Okay. After negative fraction, I ask you to, I told you the fractional powers. Fractional powers actually like negative powers. It has only one rule. This rule, I'm generally using this one, because this m, if it is equal to 1, it becomes this rule. So, and only this rule if we use, let's say 2 to the power of 5 over 7 means 7th root of 2 to the power of 5 it's going to be, which is equal to 7th root of 2 to the power of 5, it's going to be equal to 32. Then it's going to be, this is the answer, it has to be. But we are not solving these questions. For this type of questions, we are not using this indices in this topic. Especially we are going to use for this kind of cases. Like, what is 125 to the power of 1 over 3? Firstly, you should know this one. If there is a power 3, denominator 3 here, this number should have something to the power of 3 firstly. That's very important. This number to the power of 3. Something to the power of 3 it should be. And when I check this number, that's equal to 5 to the power of 3 is equal to 125, which means 5 to the power of 3, 125 to the power of 1 over 3 is equal to 5 to the power of 3 to the power of 1 over 3, because 5 to the power of 3 is equal to 125. Then it's going to be equal to 5 to the power of 3 times 1 over 3, 5 to the power of 3 over 3, then it's equal to 5 to the power of 1, which is equal to 5. I'm doing all these operations for the operation safety and to teach you. In the exam, you may skip these steps. Let's say 3 times 1 over 3, directly you may write 3 over 3. And instead of 5 to the power of 1, you may directly write 5 to 5. But for the operation safety, I need to show that one to you. Okay, the next one, 16 to the power of 1 over 4. Again, I'm going to mention the same sentence. This one here, something to the power of 4, it has to be this number. And first I'm checking that one. Which number to the power of 4 should be 16? And then I understood that 2 to the power of 4 is equal to 16, which means 2 to the power of 4 to the power of, actually 16 to the power of 1 over 4 is going to be equal to 2 to the power of 4 to the power of 1 over 4, because 16 is equal to 2 to the power of 4. And then it's going to be equal to 2 to the power of 4 over 4, which is equal to 2 to the power of 1. Then that's going to be equal to, and that's going to be equal to 2. 2 to the power of 1 here, but as I mentioned before, this is invisible power. And here, 25 to the power of 3 here over 2. And again, we are going to look at the denominator, not numerator. 3 is not important at the beginning for us. It's going to help us only to find the result, but it is not when we are searching for this number, 25 I'm talking about, we are going to check the to the power of 2 here. So 25 is the power square of which number? I should find that one. Actually, you know very well that one is equal to 25 is equal to 5 square. You know that one very well. But even in this case, we should be careful about here with the powers, which is equal to 25 to the power of, if I rewrite this one here, 25 to the power of 3 over 2 is equal to 25 to the power of actually 5 to the power of 5 to the power of 2 to the power of 3 over 2, which is equal to 5 to the power of 2 times 3 over 2, which is equal to 2, and 2 you simplify it, 5 to the power of 3, and then it's going to be equal to 125. As you see here, these are not difficult numbers. Fractional or negative indices, these are not difficult numbers, but you have to be careful about during the test. And I'm going to solve from 1 or 2 example from these questions, then 1 2 example from these questions. Do you have any question until now?
No.
No.
Okay. So 16 times 2 to the power of minus 3, which should be 16 divided by 2 to the power of 3. Because when the power is negative, we are sending down, which is equal to 16 over 8. That's equal to 2. So the answer of this one is 2, but you have to prove me in the exam like this also. Do not forget that one. Then I will choose this kind of things here. 7 to the power of 4 to the power of 2 minus 3. B I'm solving. Here, this should be like this. 4 times 2 to the power of -3 should become +3, because when it moves the other side with respect to, we are talking fraction bar, when it moves to other side, you should change the sign. So if this goes up, it means that you should change the sign like this, and it should be in times form. Then it's going to be equal to 4 to the power of 2, 4 times 2 to the power of 3, which is equal to 4 times 8. 2 to the power of 3 is equal to 8. Then it's going to be equal to 32. I calculate this one because it is easy to calculate. If it is not, I don't want you to calculate. You may leave like that. If you do this one also, it is correct for me. 4 times 2 to the power of 8, 2 to the power of 3. This is also correct answer. I'm talking about this. Okay, then we are going to, I'm planning to solve this one also here. This is 16. 16. I'm sorry, 16, page question 2. 2 and 2 to the power of 2b. Okay, now I'm going to solve this question here, or this one also similar. In the class, I remember that I solved this one. Let me solve this one also. Here, the powers are, bases are same, so we can do the calculation between the powers, but here, both of them, they are negative number. So we need to be careful about the signs. 8 to the power of -6 divided by, when it is divided by, we should subtract, which means 8 to the power of -8 it has to be. Okay, -8 it should be. Then 8 to the power of -6, actually it should be like this here. I made a mistake, sorry. Made a mistake. I should correct this one. It should be like this, 8 to the power of -6 -8 it has to be, which is equal to 8 to the power of -6 plus 8, and which is equal to 8 to the power of +2. That's equal to 8 to the power of 2. That's equal to 64. Again, I'm repeating, you may skip some of the steps, but your operation should be clear about that one. Okay, this is the now last one that I'm going to explain, last page, and I'm going to ask if you have questions. Actually, you're asking me this kind of questions, isn't it? These are the last page, and in last page, there are some questions. They're not easy for you. Here, I'm going to start with this one, 2 to the power of 16 to the power of 1/3, let's say. Again, I'm repeating, I'm looking for which number to the power of 3 is equal to 216. I'm looking for that one. 216 is equal to which number to the power of 3 it should be. And I know that that's a 6. How I know? By experience. You can easily find, when you continue to solve questions like this, you will easily find in the test also. This is going to be equal to 6 to the power of 3 to the power of 1/3, which is equal to 6 to the power of 1. That's equal to, or 3/3, you can say 6 to the power of 1. That's equal to 6. It has to be. Now I want to show the one example also here. Which one it is? Here, this one. Now, some students, they told me that 16 is equal to 2 to the power of 4, and 16 is equal to 4 to the power of 2 also. Both of them. But when there is a conflict in this kind of cases, you are going to check firstly, you are going to check this denominator, which is equal to 4. And then you should convert to 2 to the power of 4. Then it's going to be equal to 2 to the power of 4 to the power of 5 over 4, which is equal to 2 to the power of 2 to the power of 4 times 5 over 4. You may simplify this two, this one and this one. Then it's going to be equal to 2 to the power of 5. That's equal to 32. But anyway, it is not important for us. In the exam, I'm not going to calculate this kind of things unless 2 and 3. Let's say if the answer is 7 to the power of 5, we cannot calculate. We need calculator for that one. I mean, we can calculate, but it will take much time. So 81 should be the power of something. I'm looking for that one also. And this is 81. I know that it's equal to 3 to the power of 4 only. We don't have an alternate operation. And I see that this is also 4. So this is equal to 3 to the power of 4 to the power of 3 over 4, which is equal to 4 times 3 over 4, it should be. Then if you simplify the 4s, it's going to be equal to 3. So 81 is equal to 3 times 4 times, 3 to the power of 4 times 3 over 4. This is equal to these two, you may simplify, which is equal to 3 to the power of 3. That's going to be equal to 3 to the power of 7 here. And here, if there is no question, I'm going to solve the last type of questions here. And last type of questions, addition and subtraction between the fractions. Before starting to this kind of questions here, these are, I want to solve some of them here. Then I'm going to go up because I think these are more difficult here than the upper one for me. Here, the powers are with fraction. And you need to remember this one. A to the power of m times a to the power of n is equal to a to the power of m plus n. A to the power of m divided by a to the power of n is equal to a to the power of m minus n. By the way, a to the power of m divided by a to the power of n also is a fraction, so it's going to be equal to m minus n again. So here the fractions are 4 over 3 and 5 over 3, which means that we have to add 3 to the power of 4 over 3 plus 5 over 3 now. 4 over 3 plus 5 over 3, which is equal to 3 to the power of 9 over 3, actually. And that's going to be equal to 3 to the power of 3. And then it's going to be equal to 27. This is going to be 3 to the power of 3. Then it should be equal to 27. In the exam, most probably I will ask this kind of simple powers. That's why you can easily calculate and you can find the results. And here, if I check this one now, 4 to the power of, this is going to be like 4 to the power of 5 over 6 plus 5 over 6 plus 5 over 6 plus 4 to the power of 1 over 2. This is going to be equal to 1 over 6. 2. I read it down. That's why it becomes like that. 1 over 6. That's going to be equal to 4 to the power of 1 over 2. Then it's going to be equal to 4 to the power of 6 over 6. And divided by 4 to the power of 1 over 2. And here, 6 over 6 you can write as a 1, but we should do this one here. 4 to the power of 3b, let me write here. 3b, third question, and b answer. 3 to the, I made with power 3b. 3b. Then this is going to be equal to 4 to the power of 5 over 6 can be written as 4 to the power of 6 over 6 can be written 4 to the power of 1 divided by 4 to the power of 1 over 2. then this is going to be equal to 4 to the power of 1 minus 1 over 2. And this is going to be equal to 4 to the power of 1 minus 1 over 2. I can calculate in some different place, but 1 minus 1 over 2, you should do like this to see operations better. I'm not going to continue there. 1 over 1 minus 1 over 2. We are going to make the denominator same. This is 2, this is 1. And then it's going to be equal to 2 over 2 minus 1 over 2, which is equal to, I couldn't find space. Sorry to wait. Okay, then 2 over 2 minus 1 over 2, it should be equal to 1 over 2. 1 over 2. So the answer here, which I didn't write, it's going to be equal to 4 to the power of 1 over 2. This can be also written as radical expression, square root of 4 also. It might be, okay. And I'm going to, from half 35 minutes, I'm solving question. I'm going to solve the last one and I'm going to end here. Actually, while talking 35 minutes, I see that this is not easy because 35 minutes I'm talking like without break. You are not writing here now, and I didn't ask to write, by the way. Here, I need to copy this page. Okay. This one and this one is same. Why I'm doing like that? Because I'm going to clean these are like this. First, I'm going to delete these are. Then I'm going to move these questions a bit high, like this. Then we may continue here. And as I mentioned, I'm going to solve two questions. One of them is this one, and the other one is this one here. And I mean,
Teacher,
yes,
I have a question about the equation we just solved.
yes.
At the start of the equation, it's 4 to the power of 5 over 6 times 4 to the power of 1 over 6. Where does the other 4 go?
This 4, you mean?
No, the up one, the second one, that one.
But you remember from the property, if you multiply two expressions with same basis, you should add the powers. I'm adding the powers here.
So we just remove the other 4?
Yes, yes.
Okay.
5 over 6 plus 1 over 6 it has to be.
Okay, thank you.
Okay. Then this is the last part. Now, firstly, I need to make here this question a bit different than the others because these are not with same basis. Normally, this number should be with same basis, but here this is 3 to the power of 3, it should be 27, 3 to the power of 3, you know that one, and to the power of 5 over 3. And by the way, root of 9, I need to calculate as 3. You know, root of 9, it should be equal to 3. Then it's going to be equal to 3 to the power of 3 times 5. 3 to the power of 3 times 5 over 3. This 3 is simplified. Oh, pardon, all over 3 we keep here. Then it's going to be equal to 3 to the power of 5 divided by 3 to the power of 5 divided by 3 to the power of 1, which is equal to 3 to the power of 5 minus 1. 5 minus 1 now, that's equal to 3 to the power of 4. And as I mentioned, for some numbers, it's going to be easy for us. This is also 3 to the power of 4. That's equal to 81. When you multiply 3 to the power of 4 by itself 4 times 3, 3, 9. This is 9. 9 times 9, 81. Actually, these numbers are not difficult. And the last one, and then we are going to finish. Here, 2 to the power of 3, we have 8 to the power of 2. And this is only the question that doesn't fit with our answers maybe, but we can do like this also. Since we know that 2 to the power of 3, 2 to the power of 3 is equal to 8, then this becomes 8 times 8 to the power of 3 over 2. And I mentioned in the class many times, the power is 1 here, divided by 8 to the power of 1 over 2 again. Then this 2, it's going to be added, which is equal to 8 to the power of 1 plus 3 over 2. That's going to be equal to, you're going to multiply this one by this one, then you're going to add here. In the previous page, I didn't do like that. I tried to do fraction operation, but also you can do the same thing here. First, you may multiply, then you may add. 2 to the power of 1 minus 2 to the power of 2 times 1. I'm sorry, not 2 to the power of 1. 2 times 1 is equal to 2 minus 1, which is equal to 1. So the answer should be 1 over 2. Also here it is, as you see, it is 1 over 2. But here, since it is addition, directly I made the same thing here. And then this is going to be equal to 8 to the power of 2 times 1 is equal to 2 plus 3, it's equal to 5. So 5 to 8 to the power of 5 over 3 this is. 8 to the power of 1 times 2 plus 3 over 2 all over 8 to the power of 1 over 2, 8 to the power of 1 over 2. Then it's going to be equal to 8 to the power of 2 times 1, 2 plus 3, it's equal to 5. 5 over 2 all over 8 to the power of 1 over 2. Now I'm going to subtract them. 8 to the power of 5 over 2 minus 1 over 2, which is equal to 8 to the power of 4 over 2. And it's going to be equal to 8 over 4 over 2. It should be equal to 2. 8 to the power of 2, which is equal to 64. It has to be. Okay, this is the end of the lesson now. Is there any question?
No.
Okay. I'm going to stop the lesson and see you in the
Later.
Thank you,
Bye.
teacher.
Bye.
Bye.